Now that we've covered future value, let's cover present value. Recall that present value is what something is worth today. And so just as compounding is the term that refers to the process of calculating a future value, discounting is the term that refers to the process of calculating a present value. So if we want to look at this on the timeline, notice that the major difference between this timeline and the future value timelines that we saw is that the arrows are pointing to the left instead of to the right. So we're starting with $935 and we're working our way back to a present value of $702.48. Just as we did with future value, let's take a look at the formula. The present value is just the future value divided by 1 plus r raised to the nth power. In the calculator, using that example of the 935, we're going to plug in 3 for n, 10 for the interest rate, 0 for payments, 935 for the future value, and then we're going to solve for the present value. So what this is telling us is that we would have to invest $702.48 today at 10% for 3 years in order for it to grow to $935. So now if we wanted to calculate the present value of an ordinary annuity, we'll take a look at that now, in that we're discounting each of those annuity payments. So here's that annuity of $400 a year for 3 years at 5%, but now we're calculating the present value. So all we're doing here is just calculating the present value using the equation for each of those cash flows and then summing up those results. So here is our present value of an annuity formula. Payment times 1 minus 1 over 1 plus r to the n, all divided by r. So now again, in the calculator, if we wanted to solve for this, instead of having a future value in this problem, because it's an annuity problem, future value is 0 and payment is 400. And then we compute the present value. So you can think of this as saying that if we wanted to receive 3 $400 payments, we'd have to invest $1,089.30 today. So now, what if it's not an ordinary annuity, but an annuity due? For an annuity due, remember, we back up the payments one period. And so that's all we're doing in this slide, backing up those cash flows one period, solving for the present values, and adding them together. So again, our formula changes by just multiplying by 1 plus r. We change our payments to the beginning of the period in the calculator, plug it in the same way, and compute present value. Now let's take a look at perpetuities. Perpetuities are basically annuities that go on forever. And so you don't really do these in the financial functions of the calculator because it's a simple formula. It's just the payment divided by the interest rate. And so remember also, we talked about uneven cash flow streams. And so on an uneven cash flow stream, in order to calculate present value, we're going to have to use the cash flow worksheet in the calculator. But first, let's take a look at the timeline. So in an uneven cash flow stream, it's not very different from an ordinary annuity where we have regular payments, but this time the payments are unequal. So we calculate the present value of each payment or each cash flow and sum them up to get the present value of that cash flow stream. So again, we're just taking the present value of each cash flow and summing it up. So in the financial calculator, remember I was saying that we're going to use the cash flow worksheet. And so cash flow 0 is 0 because effectively that's what we're solving for. And then cash flows 1, 2, and 3 are those 3 uneven cash flows. And then you hit NPV, and it's going to ask you for the interest rate. So they've written this a little bit backwards. they ask you for the interest rate, and you'll put 5 and enter. And then in the TIBA2 Plus, you have to hit down arrow, and then it'll say NPV again, and then you hit compute.